Hello viewers, welcome to my YouTube channel. My name is Amos Ayenaba. Today I am pleased to take you through the graph of a sine function. And I'm here with my class or with my students. This lesson is going to be built on the behaviorist foundation to teaching and learning, or the behaviorist learning theory. Alright, good morning class.
Good morning, sir.
In our previous lesson, we looked at the sine function, where we said the sine function is what? Y equals to what? Sine x. Now, we derived this one from the unit what? Circle. The unit circle. What is a unit circle? James?
A unit circle is a circle whose radius is equal to 1.
A circle whose radius is equal to what? 1. Excellent. Let's give you a hand of applause. Nice one. So that was where we had this particular formula sine function from y equals to what? Sine x. So today we are not going to waste time. Today we are going to do something simple, and what you should be able to do at the end of the lesson is what I call the learning objectives. So by the end of this lesson, the learner, each of you, including the viewer, should be able to sketch the graph of y equals to sine x and state its domain and range. So you see, what you have to do is very simple. You should be able to sketch the graph of sine x, and then you should be able to state its domain and range. And so we are going to look at certain values where we will use those values to sketch the graph of sine x. So now we have with us here some angles. So we are going to use these angles together with their values and plot on a graph. So sine 0 degrees will give us what? 0. What of sine 90? 1. What of sine 180 degrees?
0.
What of 270 degrees?
-1.
What of sine 360 degrees? 0. Okay, so we are going to plot these points on what? On a graph board. So when we plot the points on a graph board, we'll be able to see the nature or the shape of the graph of sine y, and y equal to sine x. In some cases, you can also have it as y equals to sine theta, if our x is what? Theta. Is that okay? We are going to plot these angles together with their sine values. Now what happens is that this is for the y-axis. So this is, let's say, this is y equal to sine x. This is for the x-axis. So it means we are plotting the degrees on the x-axis against the values on the y-axis. So we are using a scale of what? Let's say 2 centimeters to 90 units on the x-axis. So we have what? If this is our origin 0, so 2 centimeters, so this will give us what? 90 degrees. From here we come to 80 degrees. We have what?
270.
We move to where?
360
degrees. Nice one. So this will be the x-axis. And now we have our y-axis. So the y-axis too, looking at the values we have here, we are going to label it what? Let's say 1 centimeters to 1 unit. So that will give us, here we can, this is 0, so this will give us what? 1, and this is what? 2. Here will give us -1, then what? -2. Now let's look at the plotting. The 0 degrees goes with what? 0. Sine 90 degrees is 1. While sine 180 degrees is what? 0. So let's plot that. 0 degrees is what? 0. So that means the graph will pass through the what? The origin. Now we move to what? 90 degrees is what?
1.
Positive 1. So that will be here. Now let's go to 180 degrees.
0.
180 degrees is 0, meaning it will lie on this one, on the x-axis. Then the next one is what? 270 degrees.
Negative 1.
So it will come down. Then let's go to 360 degrees.
0.
Now let's draw a line through these points and observe the nature of the curve. So from here, the line passes through the origin. It's like a curve through here. Then from here, it will go to the 180. It goes this way. From here, it goes down to here. Then from here, it goes up to here. Then it goes on and on. Is that okay? Now, what shape can you see from here? How does the shape look like? What can you relate the shape to in real life?
The wave.
It looks like what? A wave. Excellent. I like that. So this is a wave-like what? Curve. So it means the graph of sine x looks like what? A wave. It does not start from the origin, but it passes through the what? The origin. It means that here too will continue like that. Are you getting it? Whilst here also continues like that. So when we visualize it, it looks like this. It goes on and 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 on. So it is a wave-like one function. Okay. Now, let's look at the graph again. The graph has a minimum value of -1 and a maximum value of +1. So that means the range of the sine function is from -1
To
positive 1. Excellent. Good. Again, let's look at the domain. Now, you realize that any value you put here, any angle you put here, when you enter it into the sine function, you will get a result or you get an output. For instance, when you press sine 1 degrees, sine 2 degrees up to sine infinity, it will give you a result here. So any real number you put into the sine function, it produces an output. I get it. Yes. So because of that, we say that the domain of the sine function is for all real numbers, or the sine function is defined for all real numbers. So if the domain is for all real numbers, then we can say that the domain is from -1
Infinity
to positive
infinity.
Excellent. Clap for yourself. Good. I like that. Now let's look at one more observation before we bring our lesson to an end. When we study what we have here, you realize that after every 360 degrees, the curve repeats. It keeps on repeating. So when we come here, we start from here up to where? Here. You see that it will repeat again from here, taking the same form. So it keeps on repeating after every 2 pi or 360 degrees. After every 2 pi or 360 degrees. And so that is basically what the graph of the sine function is. Okay, so we have come to the end of our lesson, and I have some few questions here for us to practice. Listen attentively. If you answer the question correctly, I will give you an award. Okay, the sine of an angle in the right triangle is the ratio of the is the ratio of the opposite side to the hypotenuse side. Excellent. I like that. Keep it up. Then we have another question. The graph of y equal to sine x oscillates between a maximum value of and a minimum value of Yes. Yes.
1 and -1.
So which of them is the maximum, which of them is the minimum?
The 1 is the maximum and the -1 is the minimum.
Great, I like that. Okay, so this is all what we have for today. So in our next lesson, we are going to look at the graph of cos x, or the graph of a cos the cosine function. Thank you all for your participation.